Hello student, today we are going to learn about Runge Kutta methods. So what is the RK methods? So RK method is under the category of single step methods. So what's happened in Runge Kutta methods, and short form of a Runge Kutta method is a RK method. So in a RK method we use the iterative scheme yi plus 1 equal yi plus h plus hm, where h is a what? H is a class interval. H is class interval, length of class interval, length of class interval, class interval, interval. So what is our aim in a Runge Kutta method? Means what is the standard? We try to solve dy by dx equal fxy, and given that yx0 equal y0. So in RK method, what is our aim? Our aim is to solve first order differential equation with initial values. So initial value problem. So dy by dx equal fxy, yx0 equal y0. So as we know that RK method is under the category of a single step method. So here we use yi plus 1 equal yi plus hm. Hm is a length of a class interval of what? xi to xi plus 1. xi to xi plus 1, and m is a m equal m1 w1 plus m2 w2 plus m3 w3 up to mr wr, where m1 is a m1 m2 mr are the slopes at different point, at various point in xi and xi plus 1. And what is the w1 w2 w3? w1 w2 wr are the weights for different slopes, for various slopes. So RK method is also categorized by the different order of RK methods. What is the meaning of this one? Meaning of this one is if we use one slope between xi and xi plus 1, then RK method is called first order RK methods. If we use two slope means m1 and m2 between xi and xi plus 1, then this RK method is called second order RK method. Similarly, if we use the three slope between xi and xi plus 1 to find out the value of m, then this one is called third order RK method. Similarly, if we use the r slopes between xi and xi plus 1, then this one is called rth order Runge Kutta methods. And most popular RK method is a fourth order Runge Kutta methods. So here first we derive the RK method of a first order and RK method of a second order. So, and here w1, w2, w3 and w are the weights corresponding to the slope m1, m2, m3 up to mr. And what is the meaning of this one? As like in a previous lecture we discussed about Euler method, improved Euler method and modified Euler methods. In a Euler method we use a 1 point slope. In an improved Euler method we use a 2 point slope, average of a 2 point slope, and in a modified Euler method also we use the 2-point slope. So as the number of slopes increases, means as the M1, M2, MR, R increases, means the order of a Runge Kutta method increases, the accuracy also increases. Means in a second order Runge Kutta method, RK method have a better accuracy in comparison of a first order. Similarly, in a fourth order RK method have a better accuracy comparatively third, second and first. So what is the value for M1? M1 equal f of xi yi, and M2 equal f of xi plus a1h and yi plus v11 m1h, and M3 equal f of xi plus a2h and yi plus v21 m1h plus v22 m2h, and in a similar manner, what is the value of mr? If this one is a 3, then this one is a 2. If this one is a 3, 2, 1, 2, 2. So in a similar manner, what is the value of mr? Mr become f of xi plus ar minus 1h yi plus v r, then this become 3, then 2, then r minus 1, 1 m1h plus v r minus 1 2 m2h, and in a similar manner last one is a v r minus 1 comma r minus 1 m r minus 1 h. So if we closely observe, to find out the value of M2, we use the M1, means the value of a slope of a previous step. To find out the value of M3, we use the slope of M1 and M2, means slope of previous steps, means previous slope M1 and M2. To find out the value of MR, means RH slope, we use the values of M1, M2, M3 up to MR minus 1, M1, M2 up to MR minus 1. So this one is and this can be also written as, if R equal 1, then M1 equal f of xi and yi. If R is greater or equal to 2, then MR equal f of xi plus ar minus 1h comma summation yi plus summation, we can write this one in form of a summation. Here if we closely observe, there is a one script varies from 1, 2, 3 up to r minus 1. This one also varies 1, 2, 3 up to r minus 1. So here we write what? J equal 1 to r minus 1. And what will vary? Second script. Here second script will vary. So here Vr minus 1 comma, here we write J, and J varies from 1 to r minus 1, M, J and H. So H with the constant, so this may be written here. So this one is a what? This one is a value of a MR. Now in a first order RK method or second order RK method, third order RK method or fourth order RK method, there is a need to find out what? There is a need to find out the value of M1, W1, M2, W2, M3, W3. Then we put the values to find out the value of a what? Value of a M. Now question is how we find the value of a M1, value of a W1, W2, W3 and W4. And how we define the values of M1, M2, M3 up to Mr. Basically M1, M2, M3, Mr is defined like this one. Once we find the value of a W1, W2, W3 and these constants, to find out the value of M2 there is a need to find out the value of A1. To find out the value of M2 there is a need to find out the value of B11. Similarly, to find out the value of Mr there is a need to find out the value of AR minus 1. Similarly, VR minus 1. So, what is required to find out the first order, second order, third order, fourth order derivative? To find out the values of W1, W2, W3, W4 up to WR, and to find out the value of M1 there is a need of to find the value of A1, and to find out the value of M2 there is a need to find out value of B11. Similarly, V21, V22, V31, V32 means there is a need to find out these constant. So how we find these constant? So now we see how we find these constants. So to find out a constant, here we assume that the right hand side, this one right hand side, we have according to the Taylor series expansion. So here we write, first we write M in term of a W1 and M1, then we compare the right hand side with the Taylor series expansion. So how we derive this one? So once we write here, once we erase out this one, we erase out this one, not we erase out this one, here once we write then we erase out this one. So for first order RK method, first order RK method, what is the iterative scheme? Iterative scheme become what? Yn I plus 1 equal yi plus hm, and m become, because there is a one slope, so m become W1 M1, W1 M1. So what is the value of M1? Because there is a single slope, so this one is a slope at what? Xi and yi, xi and yi. This one is a slope, dy by dx fxy. So we try to find out the slope at xi yi for general value. At x0 y0, what is the slope? F of x0 y0. So at xi yi, what is the slope? Xi f of xi yi. Because this one is a single step method, means with the help of a xi yi, we move to the xi plus 1 and yi plus 1. And with the help of a xi plus 1, yi plus 1, we move to the xi plus 2 and yi plus 2. So what is the value? Obviously weight is 100%, so what is the value for W? W1 is a what? 1. For second order, or we write in this form, second order RK methods, so how we write the iterative scheme? Here we write iterative scheme in this way, yi plus 1 equal yi plus hm, and m is a what? M is a M1 W1 or W1 M1. If we write a W1 M1, first we write the weight, then W1 M1 plus W2 M2. And what is the value of M1? M1 is a f of xi yi, because this one is a M1. For r is a greater or equal to 2, for r equal to 2, what is the value of M2? M2 become, if we write here, M1 is a f of xi yi, and M2 is a, if we write here, not here, means what is the M1? If we write M1 here, M1 equal f of xi yi, and M2 equal f of xi plus a1h and yi plus b11 m1h. So here this one m1 we able to find out m1 with the help of a dy by dx because first order derivative is a given. But how we find the value of a m2, because here we able to find out this one with the help of a dy by dx, but a1 and b11 is unknown. So how we find the value of a11 and b11? So we put these values m1 and m2 here and using the Taylor series expansion to find out the value of a what? To find out the value of a a1, b11, w1 and w2. So here we write in this way. So once we erase this one, what is the value? If we simplify the m2, now m2 equal what? m2 equal f of xi plus a1h yi plus b11 m1h. And using the two variable Taylor series expansion. What is the two variable Taylor series expansion? Two variable Taylor series expansion of this one, m2 become f of xi yi plus a1h. Basically this one is a f of x plus h y plus k. So what is the Taylor series expansion for two variable? F of a plus h v plus k x plus h and y plus k. This one equal f of xy plus h del f upon del x plus k del f upon del y, and we ignore all other terms. We ignore the all other terms. So in this way we compare, this one is a x. If we compare, what is the value of h here? This one is a a1h. What is the value of a k here? This one is a b11 m1h. So using the two variable Taylor series expansion, m2 become f of xi yi plus h means here h is a what? H is a a1h. Then del f upon del x. So this one is a del f upon del x plus k. What is the value of a k here? The value of a k is this one. So k means a b11 m1h del f upon del y. So in place of a m2 we write here, in place of a m2 we write this one. Now what is the iterative scheme? Iterative scheme become yi plus 1. If we denote this one by the equation number 1 and this one equation number 2 and this equation number 3 and this one is equation number 4. Equation number 4. So now equation 1 become what? Equation 1 become yi plus 1 equal yi plus h m. What is the value of m? M become m1 w1 plus m2 w2. Now we put the value of m1 and m2. m1 from here, m2 from here. So obviously this one is a del f upon del x at xi yi, and del f upon del y, this one is at xi yi. Now yi plus 1 equal what? Yi plus h inside m1. What is the value of m1? F of xi yi w1 f. If we write simply f of xi yi by the f plus m2. M2 is a what? M2 is a F. This one is a, we denote this one by the F. F. First we write W2, then inside M2 F plus A1H del F upon del X. We denote this by the Fx, del F upon del X plus B11 M1H Fy, this one. So this one is a what? This one is a value of M2 W2. So Yi plus H W1, this and this one become what? W1, W2 and like this one. So what is the value of M1? We also replace M1 here by the what? M1 here by the F. So this one is the expression. So if we simplify this one, Yi plus 1 become what? Yi plus H W1F and W2F. So we equate the term of F at one places, so this become what? W1 plus W2F. This term and this term. Plus we write this term W2 A1 W2 A1H Fx plus W2 B11 F. Here we replace M1 by the F because M1 is a what? F. Fy. So this one is a required expression in this form. Means this expression using the value of a W1 M1 W2 M2. Now we come in this form. This form. Now we compare this one to find out the values of a W1, W2, A1, B11 by the Taylor-Series expansion. So what is the Taylor-Series expansion? Taylor-Series expansion of a one variable. Now what is the Taylor series? Taylor series expansion. Taylor series expansion is a what? Yi plus 1 equal what? Yi plus H yi dash plus H square upon factorial to yi double dash. Yi double dash plus order of a H cube. So we ignore all other terms. So only we write a second order. So what is the value of a yi dash? Dy by dx is a fxy. So yi dash is a what? F. So here if we write this one yi plus 1 equal yi plus h and yi dash dy by dx become fxy. So h f. Simply we in place of a f xi yi we write what? F plus h square by 2. What is the value of a y double dash if we write in term of a what? In term of a partial derivative. Y dash equal what? Y dash equal f means dy by dx. Y double dash become df upon here. Suppose here we delete this one, we erase this one, and not here. If we write what? If we write here dy by dx equal this one means y dash equal f of xy. Then y double dash equal d y dash upon dx. This means df upon dx. And this one is a d by dx of and df equal what? Df equal, we know that df equal, if f is a function of x and y, this become del f upon del x dx plus del f upon del y dy. So df upon dx become del f upon del x plus del f upon del y dy by dx. So if we write this one here, so y double dash become what? Y double dash here, del f upon del x is a what? Fx in notational form, plus fy, and dy by dx is a what? Dy by dx is a f. Dy by dx is a f. So here we write what? F. So in place of a yi double dash, we write what? Fx plus fy and f in notational form. So what is the value of a yi double dash? Yi double dash become fx plus fy f. So this one. So if we simplify this one, yi plus 1 become yi plus hf plus h square by 2 fx plus h square by 2 fy. So now we compare this result with the iterative scheme that we obtain by putting what? M equal W1, M1, W2, M2, and again by putting the value of M1, M2 here by this expression means M1 equal this, M2 equal this. So now we compare this result with this result. And suppose this one is equation number 5 and this one is equation number 6. Now we compare the equation 5 and 6. So if we compare the equation 5 and 6, because 6 is obtained by the Taylor-Series expansion and this one is obtained by the RK method, iterative scheme of RK methods. So term by term comparison. So if we compare term by term, then what is the result? Here we try to write the result by comparing the term by term of a iterative scheme of a RK method and the expression that we obtained using the Taylor-Series expansion. So if we compare here, so this one is a multiple of h, w1, w2, f. So first term equal, and this one give the what? W1 plus W2 by comparing these two. Comparing 5 and 6. W1 plus W2 become what? W1 plus W2 become 1. This one, coefficient of this one and multiplied by here. H, W1, W2 equal H cancel out. Now, if we multiply here, H, this become W2 A1 H square Fx. So this one is a H square by 2 Fx. So W2 A1 equal 1 by 2. W2 A1 equal what? 1 by 2. And if we compare the last one multiplied by h, then this become what? Here we miss the h, the term h. So this become what? Here because this one is a M1h. So here we miss the term h. So this become multiplied by h, then this become h square. So h square by 2 ffy. H square by 2. And this one multiplied by h here, then this become h square. Then what will happen? W2 B1 1 equal what? This one is again 1 by 2. So this one is a value. So here there is a 3 equations. W1 W2 equal 1, W2 A1, W2 B1 1. So there is a 4 unknowns, 1, 2, 3 and 4. W1, W2, A1, B1 1. There is a 3 equation and 4 unknown. So we cannot find the unique solution. We cannot find a unique solution. So By choosing any arbitrary constants of a W1, means if we choose W1 equal what? W1 equal 1 by 2. Then, what is the value of a W2? W2 become what? W2 become also a 1 by 2. W2 become 1 by 2. If W2 become 1 by 2, then what is the value of a A1? A1 become 1 and B11 become what? 1. So, for one value of a constant means if we choose W1 equal 1 by 2, then this one is a one interpretation of a RK method. If we choose another value of a W, then this one is a second interpretation of a second form of a RK method. So how many form of a second order RK method? There is an infinite form of a second order RK method because there is an infinite number of a solution. There is no any unique solution because there is a 3 equation and 4 unknowns. So by choosing any arbitrary constants, we able to find out the value of a W1, W2, A1 and B11. So once we find the value of these constants, then we able to write a iterative scheme. So what is the iterative scheme? Here we try to write the iterative scheme of a second order RK method. Second order RK method. What is the iterative scheme of a second order RK method? Second order RK methods. RK method. Second order RK methods. So in a second order RK method, yi plus 1 equal what? Yi plus hm, and m is m equal W1. What is the value of a W1 here? 1 by 2. 1 by 2, yeah, m1, 1 by 2 m1 plus 1 by 2 m2. Or you may also write this one 1 by 2 m1 plus m2. 1 by 2 m1 plus m2. And what is the value of m1? m1 equal f of xi yi. And m2 equal f of xi plus a1. A1 is a what? 1. So 1h means x1h, xi plus h, yi plus b11. b11 is again a 1, and h, m1 is a what? F of xi yi. Xi yi. So this one is a what? This one is a m2. So if we closely observe m1 and m2 here, so this one is a nothing is second order RK method by choosing the value of a W1 equal 1 by 2, then W2 become 1 by 2, A1 become 1, B11 become 1. So this one is a nothing is second order RK method look like not a look like, this one is a modified Euler method, not a modified, improved Euler method, improved Euler methods, improved Euler method, improved Euler method. And this one is also known as a Hume's method, Hume's method, Hume's method, Hume's method. So Hume's method. And if we recall, when we study the improved Euler method, then in an improved Euler method we use the slope of at 2 points between xi and xi plus 1 at xi and xi yi and xi plus 1 yi plus 1. So this one is nothing is slope at xi yi and slope at xi plus 1. Xi plus h is a what? Xi plus 1, and this one is a what? This one is a yi plus 1. So average of these two slopes. So in an improved Euler method also we use what? Improved average of two slopes. But what will happen if we choose what? If we choose what? W1 equal to 0. If we choose W1 equal to 0, then what is the value of a W2? W2 become what? W2 become 1. If W1 equal to 0, then W2 become 1. If W2 become 1, then what is the value of a A1? A1 become what? A1 become A1 become 1 by 2 and A2 also become what? B11 also become what? B11 also become 1 by 2. Now, what is the second form of our RK methods? Second order RK method, if we choose the W1 equal to 0, W2 equal to 1, then what is the iterative scheme? So this one is a what? This one is a Hume's method and this one. And if we choose the W1 equal to 0, W2 equal to 1, then what will happen? Yi plus 1, I plus 1 equal Yi plus Hm, and M become what? M equal W1, since W1 becomes 0, so W2 become what? 1. W2 become 1. So M equal 1 M2 only. M equal what? M2. And what is the value of M2? M2 become f of xi plus a1h. What is the value of a1? 1 by 2 plus 1 by 2 h. And yi plus b1. b1 is a what? 1 by 2. 1 by 2. M1 is a what? M1 is a f of xi yi. F of xi yi. F of xi yi. So 1 by 2 f of xi yi b1 and h. So this one is a what? So if we closely observe and recall the modified Euler method. So this one is a what? This one is a modified Euler method. So this one is nothing else. If we talk about a what? This one is a modified Euler method. 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 And this one is also known as a what? Polygon method. Polygon method. Polygon method. Polygon method. So what we observe, if we talk about second order RK method, then in a second order RK methods, this one is a general scheme, means yi plus 1 equal yi plus hm, m equal w1 m1 plus w2 m2. So if we putting these values here and write the value of m2 using the Taylor series expansion for two variables and compare with the Taylor series expansion of any function, means dy by dx equal fxy, if we write a value for yi plus 1 using the Taylor series expansion and compare, then we find the values of these three equations. These three equations with four unknowns. So there is not a unique solution, there is an infinite number of solutions. So there is an infinite number of ways to express the second order RK methods. So if we choose the W1 equal to 1 by 2, then this one gives the what? Improved Euler method, which one is also known as a Hume's method. If we choose the W1 equal to 0, then this become what? The RK method of a second order become a modified Euler method, and which one is also known as a polygon method. And there is a Ralston which gives as a RK method, as a Euler method, if the truncation error is less, then method is more accurate. So in a Ralston, what do? Ralston do means he choose different values of a W1 and W2. He choose the W1 equal 2 by 3 and W2 equal 1 by 3. So in this way he find the value of A1 and B11, and so that there is a minimum truncation error. So what we say that here in a second order RK method, there is a different ways to choose the value of a W1 and W2, and similarly if we choose the different ways, means a different W1 and W2, then we find a different value of a A1 and B11, then there is a different form of a second order RK methods. But most popular RK method is a fourth order RK method. Since the derivation of a fourth RK method is a very complicated, very tedious, so I am going to directly use the RK method of a fourth order. And most popular form of a RK method is a what? RK method of a fourth order, because here we use four slopes, M1, M2, M3 and M4. So now we're going to discuss about fourth order RK methods. So which one is a very popular? What is the RK method of a fourth order? Fourth order RK methods. RK method. So as we know that in RK method we use different slopes. So if we use the four slopes to find out the value of a m, then this one is called what? Fourth order RK method. So if we write a first order differential equation dy by dx equal fxy and yx0 equal what? Y0, then what is the iterative scheme of a fourth order RK methods? Iterative scheme is a what? Iterative scheme is a yi plus 1 equal yi plus hm, where m equal m1 plus 2m2 plus 2m3 plus m4 divided by 6. Means what is the value for W1? 1 by 6. W2 is a 1 by 3. W3 is a 1 by 3. W4 is a 1 by 6. And what is the value for M1? M1 equal f of xi yi, and M2 equal f of xi plus h by 2 f of xi plus h by 2 yi plus m1h. And what is the value for M3? M3 equal f of xi plus h by 2 and yi plus m2h. And what is the value for M4? M4 equal f of xi plus h and yi plus m3h. So m1h by 2, m1 by 2, and this one is m2 by 2. So this one is RK method, one form of a fourth order RK methods. So yi plus 1 equal yi plus hm, m equal m1 plus 2m2 plus 2m3, m4 divided by 6, m1 equal f of xi yi, m2 equal f of xi plus h by 2 in yi plus m1h by 2, and m2 equal f of xi plus h by 2 yi plus m2h by 2, and m4 equal, this one is m3, and m4 equal f of xi plus h and yi m3h. So this one is one form of a fourth order RK methods. So here m1, m2, m3, m4 be the slope, and how we find the values of m1, m2, m3, m4. So this one is as usual like a second order RK method that we derived earlier. We able to find out the value of a1, a2, a3, a4, b11, b21, b31, v22, v32, v33, like this one. Then we find this form of a expression. So now how we solve any numerical problem using the fourth order RK method. So just we write one problem and try to solve the numerical problem. So now we solve a numerical problem, means example, solve dy by dx equal x square plus y square initial condition is given y0 equals 0 and solve this one, estimate the value of y 0.2 by fourth order RK methods. Fourth order RK method, and choose the value of h. Choose the value of h equals 0.2. For sake of simplicity, here we choose the value of h equals 0.2. H equals 0.2. So you may choose the value of h equals 0.1 and 0.05 like this one, as the value of h is smaller than accuracy increases. So here, what is the iterative scheme of a fourth order RK method? Here already we noted down the iterative scheme of a fourth order RK methods. So how we find the value of a y1? By choosing I equal what? I equal 0. If we put I equal to 0 in iterative scheme, I equal 0, then what will happen? This iterative scheme become y1 equal y0 plus mh, and m become what? m1 plus 2m2 plus 2m3 plus m4 divided by what? Divided by 6. Now what is the value of m1? For this iteration, the value of m1 become f of x0 y0. F of x0 y0, because this one is f of xi yi. So what is the value of f of x0 y0? F of x0 means x0 be the what? 0. 0, 0. What is the value of this one? 0. So value of m1 is a what? Value of m1 is a 0. What is the value of m2? m2 equal f of x0 plus h by 2. H by 2, comma, y0 plus m1 h by 2. m1 h by 2. So what is the value for this one? Value for this one is f of x0 becomes 0. H is 0.2 divided by 2. This becomes 0.1. 0.2. H is 0.2 divided by 2. This one is 0.1. Y0 is a what? Y0 is a 0 and M1 is already 0. So the second term become what? 0. Second term become 0. So what is the value of M2? X square plus y square, because fxy is a what? This one. This one is M1. So if we compare with the standard form, means dy by dx equal fxy, then fxy equal what? X square plus y square. So this become 0.1 square, then this become 0.01. This one is the value of M2. Similarly, what is the value of M3? M3 equal f of x0 plus h by 2 y0 plus m2h by 2. m2h by 2. So here, what is the value for this one? F of 0.1, comma, what is the value for y0? Y0 is obviously, y0 is a 0 plus m2 is a what? 0.01 into h into 0.2 divided by 2, and this become what? This become is a 0.01 f of 0.1 means a 0.1 h by 2, 0.1 comma 0.001, 0.001. This one is a value. So if we put f of xi yi here, x square plus y square, then this one also become, after simplification, this become what? 0.01. Now what is the value of a M4? How we find the value of a M4? We find the value of a M4, if we write here, not here, if we write here, what is the value of a M4? If we, M4 become M4 f of x0 plus h and y0 plus m3h. So what is the value for this one? F of x0 is a what? 0 plus h is a what? 0.2, y0 is a 0 plus m3 is a what? 0.01. 0.01. So what is the value for this one? 0.01. So 0.01 into what is the value of h? 0.2. This one is the value of a 0.2. So this become what? F of 0.2 comma, and if we multiply this one, this becomes 0.002. So if we put here, what is the value for this one? 0.2 square of 0.2 plus square of 0.002 square. So what is the value for this one? If we simplify this one, this become what? This become up to 6 decimal places, and this becomes 0.04. This one is the result. This one is M4. So now what is the value of M? M is a M1 plus 2M2 plus 2M3 plus M4 divided by 6. So if we find the value of M, M is a what? M1. M1 is a 0 plus, what is the M2? M2 is a 2 into 0.01 plus 2 into 0.01. This one is a M1 plus 2M2 plus 2M3 plus M4. M4 is a what? 0.04 divided by what? Divided by 6. So after simplification, this one become 0.02, and this one also become 0.02, and 0.02, 0.02, 0.04. This become 0.08 divided by 6. So if we simplify this one, 0.08 divided by 6, this become 0.01, 6 1s are 6, and this become 220, 6 3s are. So 6 3s are, this become what? 0.6 3s are 18, 6 3s are 18, 6 3s are 18. This one is a value. 6 1s are 6, 2 8, 6. So this one is a value of a M. This one is a value of a M. This one is a value of a M. Now, what is the value of a Y1? If we put here, Y1 equal what? Y1 equal, Y0 is a what? Y0 is a 0 into plus M. M is a 0.0133 and 3 also, 1 3 also, multiplied by what? Multiplied by 0.2 H. So this become what? So this one becomes 0.002 and so on. So this one is a value of a Y1. Y1. So in this way, be able to find out the value of a Y1. Similarly, if there is a need to find out a value of a Y at x equals 0.4, then we perform one iteration more by choosing the value of a x1 is a what? X1 is a 0.2, means x0 plus h. X0 plus h is a what? 0.2. And Y1 is a what? 0.00266, like this one. So this one is all about a what? This one is all about a fourth order RK method. Not a fourth order RK method of a first order, RK method of a second order, and RK method of a fourth order. So if we summarize the Runge Kutta method is based on a average of different slopes taken at various points from xi to xi plus 1. So if we take a slope of 2 points and choose the values of a w1 equal 1, then W1 equal 1 by 2, then this become what? Improved Euler methods, Hume's methods. Because improved Euler method is also known as a Hume's method. If we choose the W1 equal to 0, then this become what? This become polygon methods. Polygon method, and it's also known as a modified Euler method, and also here we choose the 2 points. Average slope of a slope, we use the slope at 2 points. Similarly, if we use the slope at 4 points between xi and xi plus 1, at 4 point we take the slope and find the average of these slope. Then if we define iterative scheme, then this one is a what? This one is a that we earlier defined. This one is a one form of a RK methods. So this one is all about RK methods. So thank you watching my videos. Thank you.